Most CI/CD tutorials show you green pipeline, but production doesn't work like that. Your pipeline can say success, and your application can still be completely broken. If you ever deployed something and it didn't work, even though everything looked fine, this is exactly what we are going to fix. This is not a copy paste tutorial. In this 2 hour project, we are going to build a real CI CD pipeline, then break it, debug it, and fix it like it happens in real production because that's what actually matters. By the end of this, you'll understand how to build a CI/CD pipeline from scratch, how Docker exactly fits into the workflow, how to deploy it to Kubernetes, how to debug when things go wrong, and how to think like a DevOps engineer, not just follow steps. If you can explain this project, you're already ahead of most DevOps candidates. I also created a full repository for this entire setup. You can run everything locally, follow along, and build it yourself. But don't just watch this video, pause, try things, fail yourself. That's where the real learning happens. I recommend you start with the free version first, go through the entire series, do the hands on, and understand how everything works. Then, if you want to go deeper, I created a more detailed version of this setup where I go deeper into production grade Docker files, more detailed pipelines, and step by step debugging. I also added practice exercises, what to break, what to observe, and how to actually debug issues yourself. Along with that, we have interview questions, common mistakes, and a fast checklist you can use while working. This is for people who are serious, not just watching, but actually building and improving. I'll put the link in the description if you are interested. By the way, I spent a lot of time building this entire setup for the past month, breaking it, fixing it to make it realistic. So, if this helped you even a little, just hit like and drop a comment. It tells me you want more real DevOps content like this. Alright, now enjoy the series. I've seen CI/CD pipelines that were green for months. Every commit was passed, every deploy was successful, and then one small change went in and production went down. Not because of bad code, but because the pipeline was giving a false sense of confidence. If you want to build a CI/CD system that actually survives production, subscribe right now and comment CI/CD. I'll share the full project with you. This is what most pipelines look like. Test passed, deployment successful, everything is green, but production is already broken. And this is exactly how real outages happen. Here's what we are building. A developer pushes the code that triggers a pipeline. Inside the pipeline, we build the application, we run tests, add security checks, package into a Docker image, followed by we are deploying it to Kubernetes. Simple flow, but every single step here can fail in production. And in this series, we are going to break all of them. Builds can fail, tests can lie, containers can be insecure, deployments can crash, and most pipelines don't catch these problems. That's what we are fixing. Let's build this from scratch. I'm keeping the application simple because the focus is not the application, it's how the pipeline handles the application. This is just a basic application. Right now, we don't care about features. We care about how this code moves safely through the pipeline. In real systems, we don't deploy raw code, we package it into containers. So, I'm trying to add a basic Docker file. We'll actually use this in the pipeline in the next video. Right now, just understand that this is how applications are packaged. This works, but it's not production ready yet. This is where everything happens. This particular file defines the behavior of our entire CI/CD system. Here, this is just the pipeline name, and if you look at these lines of code, this defines the trigger whenever code is pushed to main branch or development branch, the pipeline runs automatically. This is critical because in production, you don't want manual steps. Now we define a job. Think of this as a unit of work. This particular job runs on Ubuntu latest virtual machine. Always it runs on a clean machine. That means no hidden state, no surprises from previous runs. First step is to get the code. Without this, the pipeline has nothing to process. This particular step helps us see what the pipeline sees. Debugging pipeline starts with visibility. And this is just a simple confirmation step. Right now, the pipeline is basic, but this is exactly how real systems start in projects. All right, let's try to add this code to the repository real quick by using git add. Now let's try to commit the code initial pipeline. Followed by, I'm going to push this git push origin main. Press enter. All right, let's look at the repository now and let's look at the actions. I do not see any kind of actions running. I'm going to click on code and also I can see the pipeline.yaml file, but there is some problem. What exactly is that? In general, we should have this .github workflows in the root location of the repository. But right now it is inside this 01 pipeline foundation folder. That's the reason it is not working. This is our first mistake and first problem which we are going to solve now. I'm going to jump back to the Visual Studio Code and try to move this real quick. So right now, if you see, it is in the root location of the repository, and I'm going to say git add followed by git commit -m move pipeline to root location. Then I would say git push. Now jump back to the repository once again and see if the pipeline got triggered. Now we can see the pipeline got triggered successfully. Let me open the pipeline real quick. It's running and also it passed. Let me open the pipeline steps. Setup job looks fine. Checkout code, listing files, echo message, printing. Everything looks green. If you look at the pipeline, it's green, but honestly, this pipeline is useless. There is no build, no test, no validation. If this was, if this was production, you'd think everything is fine until something breaks. And that's the dangerous part. A pipeline that always passes can still fail you. In the next video, we are going to actually make this pipeline useful. We'll add real build steps, Docker image creation, and test execution. And I'm going to break it on purpose so you see what real failures look like. If you are serious about DevOps, subscribe and comment CI/CD. I'll send you the full project. Thank you for watching and see you in the next video. In the last episode, we built a CI/CD pipeline. Everything passed, everything was green, but here's the truth. A pipeline can pass and your application can still be completely broken. And this is one of the most dangerous mistakes in DevOps. So, before we go further, if you are someone who wants to learn real world CI CD, not just copy paste tutorials, hit like on this video, comment CI CD below, and share this with someone learning DevOps. That genuinely motivates me to create more real world production content like this. Now, let me show you something that most videos will not show. Today, we are building a real CI pipeline. We'll add Docker build, run the application, and test it. But more importantly, we are going to expose a problem, a pipeline that looks perfect but is actually lying to you. This is the new pipeline which I created, ci build test.yaml. In this pipeline, we are going to add those steps. This is the name of the pipeline, ci pipeline build and test. And if you look here on push, previous episode we had branches main and dev. In this episode, the pipeline is scoped to this particular folder 02 CI build and test. That means only changes in this folder trigger it. This is how real systems are designed: controlled, scoped, predictable. Followed by, we have jobs, build test runs on Ubuntu latest. Then default run working directory is 02 CI build and test. And the first step is checking out the source code. Now we move from theory to actual execution. So for that, I'm going to say hyphen name followed by build Docker image. Then run colon Docker build hyphen T CI CD prod space dot. The next step is once again name run container followed by run space docker run hyphen d hyphen p port 5000 colon 5000 space hyphen name. Here I would give a name as prod container space CI/CD prod. I'm going to save this file. This is where CI becomes real because we are not testing code, we are testing the behavior. Followed by, now I would like to add another step saying wait for application run colon sleep 5. We wait for the application to start. This looks simple, and honestly, this is what most pipelines use, but this is already a problem. Then we are going to add a next step that would be fake test, enter, and run colon space echo all tests passed successfully. Everything looks perfect here. We are trying to build here, run, and also test. This looks like a production ready pipeline. But this is where things start to break. Now, I am going to open the application.py file. In this file, we are going to update this line. Here, I am going to raise an exception saying application is broken. Save this. This would crash in production. Let's push this and watch carefully. Add these changes. Git commit -m added build and test CI pipeline. Followed by, I'm going to push this code. Pipeline passed. Everything is green. Test passed. Application is broken. If this surprised you, just hit like on this video because this is exactly what happens in real production systems. This is the illusion of CI/CD. Pipelines don't guarantee correctness. They only guarantee execution. If your tests are weak, your pipeline becomes dangerous because it gives you confidence without validation. Now we fix the first problem. We don't trust fake test. So I'm going to remove this step. Followed by, we validate the actual application. For that, I'm going to say real health check. Now we are going to run this command curl http localhost port 5000. I'm going to save this. If the application fails, the pipeline fails. And also, as I said previously, waiting for application run sleep 5 seconds. This is very big problem. I am going to replace this. Now, this is important. Earlier, we were just sleeping for 5 seconds. Now, we are actually checking if the application is ready. Also, we are trying it multiple times. If the app responds, we are continuing. If it doesn't, we fail the pipeline. Because retry without failure is dangerous. It gives the illusion that things are working when they are not. A pipeline that waits but never fails is still broken. And finally, we are doing a cleanup. For that, I am going to run cleanup container if always run docker stop prod container and docker rm prod container. Pipelines should always clean up after themselves, otherwise, they become unpredictable and debugging becomes harder. Now, let's try to push all the changes which we made so far. Git commit -m, add real validation step. I'm going to push. Now, let's look at the pipeline once again and see what exactly is happening. It is trying to set up job, checking out the source code, building the Docker app image, and there it is. The pipeline failed. Not because something went wrong in the pipeline, but because something was already wrong in the application. Earlier, this same exact pipeline was passing, everything was green, and it gave us confidence, but that confidence was false. Now, for the first time, this pipeline is actually telling us the truth. This is what a real CI pipeline should do. Not make you feel safe, but make you aware. Before this, we were just executing steps. Now we are validating behavior, and that's the difference. Because CI/CD is not about running commands, protecting production. A pipeline that fails when it should is a good pipeline like this. A pipeline that always passes is dangerous. Failure is not a problem in CI/CD. Silent success is. If you ever trusted a green pipeline, this should worry you. Just hit like on this video if this makes sense. But now the question is, how do we fix this properly? Because in real systems, you don't just make it green, you fix the root cause. Let's jump back to our Visual Studio Code, and I'm going to update this application code once again and run it with return space CI/CD prod running. I'm going to save this and push the changes real quick. Git add git commit -m update application code. I'm going to push this. The pipeline is good, but the problem is with the application code, which we fixed. Now let's look at the pipeline. I'm going to open another tab real quick. Here, click on actions, and there it is. The pipeline passed. But this time, it actually means something. Earlier, we had a pipeline that passed even when the application was broken. Now, we have a pipeline that only passes when the system is actually working. This is the difference, not between success and failure, but between false confidence and real validation. A CI pipeline is not there to make things green, it's there to protect production. And if it fails when it should, that's not a problem. That's the system doing its job. And now we build, we run, we validate, and we clean up containers. This is what a reliable pipeline looks like. If this changed how you think about CI CD, do me a small favor. Hit like on this video, comment CI/CD below, and share this with someone learning DevOps. That tells me you want more real world content like this. In the next episode, we are going to break something even worse. Because right now, this pipeline is not secure at all, and most engineers don't even realize it. And that's where things get really interesting. Thank you for watching and see you in the next video. Your CI/CD pipelines might be working perfectly, builds pass, deployments succeed, everything looks secure, but your secrets could already be exposed. And the worst part, you might not even know it. I've seen real production systems where secrets were leaked not because of hackers but because of bad pipeline design. So, before we start, hit like on this video, comment CI/CD below, and share this with someone working in DevOps because this one single mistake can expose your entire infrastructure. And today I'm going to show you exactly how it happens step by step. In the last episode, we fixed correctness. We made sure the pipeline fails when the application is broken. Now we go deeper. Security. Because a working pipeline is not a secure pipeline. And this is where most engineers fail. They think I used secrets, I am safe, but that's not how it works. Security is not about using secrets, it's about how your system handles them. Now let's look at the project. We have a simple Flask application, a Docker file, and a CI pipeline. Looks simple, but we are going to use this to simulate a real production mistake. Now, I am doing something intentionally wrong. I am exposing the API key in the response. This is bad practice. But surprisingly, this happens in real systems more often than you think. Now let's look at the pipeline. I'm trying to use the same pipeline which we used in our previous episodes. So here we are going to add a secret. I'm going to say hyphen name colon set secret. Run echo API key my super secret key. Followed by I'm going to add this to the GitHub environment variable. Save this. Followed by I am going to use this secret in this line. Now let's look at the pipeline carefully once again. If you see, we are trying to set a secret directly inside the pipeline, and we are trying to hard code this. This is the first mistake. It works. It looks clean, but it's completely insecure. Now, let's try to run this. Also, I would like to look at the logs in the next step. For example, name would be show logs followed by run docker logs prod container. Save this. Now I'm going to push all of these changes to the repository. I'm going to commit these changes, add secure pipeline. Now I'm going to push these changes. Now let's look at the pipeline. I'm going to open that pipeline, build and test. And here if you see, it's trying to build the image. And there it is. The secret is exposed in logs. Anyone with access to this pipeline can see it. Logs are stored, logs are shared, logs are searchable, which means your secret is now compromised. This is how production secrets get leaked. If this surprised you, hit like on this video because this mistake is everywhere. Now we move the secret to GitHub secrets. For that, I'm going to go to the settings, and in settings, I'm going to scroll down secrets and variables, click on actions, and in action, I'm going to click on new repository secret. Here, I'm going to give API key followed by the secret value. For example, ABC123. Add secret. Now we added the secret. Now GitHub encrypts this. It is not visible in code. It is not exposed directly. This is how secrets should be stored. Now let's jump back to our pipeline. Here in the pipeline, I'm going to add environment variable. For that, I would say environment followed by API key colon secrets dot API key. Also, I'm going to remove this part of the code set secret from here. Save this file. And we are using this API key from the environment variables in this particular Docker run command. Now we inject the secret securely into the pipeline. No hard coding, no exposure in code. Everything looks secure, right? Now let's try to push these changes real quick. Git add, git commit -m update secrets, git push. Now let's look at the pipeline once again, and if I look at the logs, I can see API key colon star star star. Now this is interesting. We are still printing the API key, but we don't see the value anymore. Instead, we see stars. So what's happening here? GitHub is automatically masking the secret, which means it detects the value and hides it in the logs. So at first glance, this looks secure. But this is where most engineers make a mistake. They think I can't see the secret, so I'm safe. But that's not true. The application is still exposing the secret. GitHub is just hiding it from the logs. Masking hides the problem, it doesn't fix it. If someone has access to the container or the running application, they can still access the secret. So the issue is not visibility, the issue is exposure. If this changed how you think about CI CD, just hit like on this video because this is real DevOps. Not just tools, but understanding what's actually happening. Now we fix the real problem, not the pipeline, the application itself. Return application is running with secrets management. First rule of security, never expose secrets, not in logs, not in responses, not anywhere. This is non negotiable. Now, you might be thinking, can we add masking in the pipeline? In this particular case, we don't need to because GitHub already masks secrets automatically. So, adding masks here doesn't really change anything. Masking is definitely useful, but here the real fix is not masking. The real fix is making sure the secret is never exposed at all. Security is not about hiding secrets, it's about not exposing them in the first place. Now, if you look carefully, the whole pipeline, this is called a secure pipeline. No hard coded secrets. Secrets are injected securely. GitHub handles masking automatically. And most importantly, the application does not expose them. This is the difference between using secrets and handling them correctly. Now the pipeline is green and the system is actually secure. No leaks, no exposure, no false confidence. This is what production ready CI CD looks like. A broken pipeline wastes time. An insecure pipeline can cost you everything. CI/CD is not just automation, it's responsibility. If this video helped you understand real CI/CD pipeline, do me a small favor, like this video, comment CI/CD, and share it with someone learning DevOps that tells me you want more real world content like this. And in the next episode, we go even deeper into production failures because most pipelines are still not production ready. Thank you for watching and see you in the next video. Let me show you something dangerous. Your pipeline is green, deployment is successful, everything looks perfect, and your application is still down. No errors, no warnings, nothing obvious, and this is exactly how real production issues happen. So before we start, like the video, comment CI/CD, and share this with someone learning DevOps. Because today we are not just building a pipeline, we are debugging a real system. Up to now, we built a pipeline that works. It builds, it runs, it validates, even handles secrets securely. So, technically, everything is production ready, but there is one problem. We've been running everything on GitHub infrastructure, and that limits us because if the pipeline runs on GitHub servers, I can only see logs, and real debugging doesn't happen in logs, it happens in the system. So instead of using GitHub hosted runners, I am going to run this pipeline on my own machine. So let's set up a self hosted runner first. I'm going to click on new runner and click on new self hosted runner. Select the operating system. I'm using Linux x64, and here I'm going to follow the exact same instructions provided by GitHub. I'm going to open my terminal real quick, followed by let's try to bring in the terminal here, and it is asking me to create a folder and cd into that particular folder. So I will say make directory actions runner, then I'm going to change directory into that folder. So right now I'm in GitHub actions runner folder, followed by it is asking me to download the latest runner package. I'm going to copy this and run that same exact command, which will download that package locally in our folder on our Ubuntu virtual machine. So if you are new to my channel, I showed you how to create a virtual machine. You can watch that video. I'll try to put that link in the description. All right, let's continue. Then validate the hash. So I'm going to follow the exact steps provided by the GitHub actions. It says okay, looks good so far. Now extract the folder. I'm going to run tar command to extract the folder. Let me copy this once again. Press enter. It will try to extract the tar file. Then it is asking me to create the runner and start the configuration experience. So I'm going to copy this once again and run that script, exact script which we have locally on our machine. Everything is extracted in this folder. Press enter. It is asking me for, yeah, connected to GitHub runner registration. Enter the name of the runner group to add this runner to. I'm going to leave it as default and enter the name of runner. Press enter for DevOps lab. I'm going to leave that as DevOps lab, followed by it is asking me this runner will have self-hosted labels. Enter any additional labels. I would like to skip this. Let's keep it as it is, self-hosted. If you want to give some other label, you can give that. And then it is asking me enter name of the work folder. I'm going to leave it as it is. All right. Now looks like the configuration is done. Last step is to run this. So I'm going to run that script real quick. Run.sh. So connected to GitHub listening for jobs. All right. Let me refresh this real quick. And let's jump back to GitHub actions here real quick. And then I'm going to click on runners and self-hosted runners. If you see, we have DevOps lab. Now we have the runner connected to our own repository production CI/CD system. I'm going to jump back to Visual Studio Code. Here we have the application source code, episode 4, deployment success, but application is down. And also I created a deployment pipeline. It's almost similar to our previous pipelines. I'm going to explain that real quick. And here I'm going to write it as self-hosted. So previous pipelines, if you remember, For example, I'm going to jump back here. It was running on Ubuntu latest. Now, in this pipeline, it will run on self-hosted machine. That means it is running completely on our own infrastructure where we have full control. All right. So working directory is like the same 04 deployment success, but application is down. Checking out the source code, and also I'm trying to clean up the old container if something is running. Then followed by we are trying to build the Docker image, running the container, waiting for the application, and deployment successful. That's it for the pipeline part. Now I'm going to show you the application code. For example, this is the application code, very simple. From the previous episodes, if you remember, this is very simple application code we are using, and we have a Docker file as well, if you remember. Now let me add all these changes real quick. Commit -m, add a new pipeline, git push. Now I'm back to my GitHub repository. So we added a new pipeline, deployment failure, add a new pipeline. It started running already. Let's see where exactly it is running. So I'm going to click on setup job. If you see current runner version, runner name DevOps lab, runner group default, machine DevOps lab. So it is running exactly on our machine right now. If you see, listening for jobs, running job, deploy right now. All right. So build image failed. So we see an error right now. Failed to build Python pip install requirement.txt did not successfully completed. So there is some problem going on. Looks like failed to build, failed to solve bin sh. Let me jump back to my Visual Studio Code, and if you see in this particular folder, I do not have requirements.txt file. That is the reason it is failing. I'm going to copy this real quick and let me paste it in this particular folder, followed by I would say git add git commit -m add requirements text file, git push. Let's see if we can pass that particular error. All right, looks like Docker build image is fine now, also running the container, and then waiting for application deployment success message. All right, now if you see very carefully, here we have a green pipeline. It built the image, it ran the container, and also you can see deployment success message. That means if I jump back to my terminal, here I should be able to access our application on localhost port 5000. Here I see an error, connection reset by peer. But wait, our pipeline passed successfully, but then application is down. This is where most engineers panic, and most people start guessing here, restart things, blame tools. But real debugging starts with observation. Now the first step is to check whether the container is running or not. It is up and running fine, followed by the next step is Docker logs prod container. Press enter. And if you look here very carefully, I can see the container is running, but it is running on port 5001. But if you see Our container is running on 5000 and the application is running on 5001. So internally it works, externally nothing is connected. That's why we see deployment succeeded but routing failed. Now let me jump back to the Visual Studio Code. Let's look at the application code, and in here I see 5001 that I need to correct. So this is not a pipeline issue, not a Docker issue, the system application code. Now let me real quick add that, followed by git commit -m update port. I forgot to save the file. Once again, git add update port and then push. So the pipeline is running once again. Let's see what exactly will happen now. All right, the pipeline ran successfully once again. Let me jump back to my virtual machine. Now let's try to run the curl command on port 5000 and see what kind of output we are going to get now. Press enter. If you see now, I get a message saying application is running. Now it works perfectly as expected. A green pipeline can lie, a working system tells the truth. If this made sense, like the video, comment CI/CD and share it, because this is real DevOps, not tools, real thinking. And this is why debugging is your most important skill. Thank you for watching and see you in the next video. Most people think CI/CD ends when the pipeline is green, but that's not production. Production starts when your code runs on real infrastructure. Today, we are taking our CI/CD pipeline and deploying it to Kubernetes cluster. If you are serious about DevOps, not just tools, subscribe now, because this is where most tutorials stop. We are creating a new folder here named K8's deployment. In that, we have application source code, Kubernetes files, Docker file, and requirements.txt file. I created a new YAML file, deploy Kubernetes. It consists of same exact steps which we had in our previous episodes, but we are trying to improve the same pipeline. In general, in real production environments, you are going to optimize your existing pipelines. You're not going to create all these separate pipelines. Just for simplicity, I'm trying to create new pipelines here, but in real production environments, you are going to update the existing pipelines. All right. So if you remember from our previous pipeline, we had run container, wait for application, and then deploy success message and security related stuff. I'm not going to explain all of that. If you are new to my channel, please check the previous episodes. So first things first, here we are trying to deploy to Kubernetes cluster. This is very simple. Kubernetes apply deployment.yaml, Kubernetes apply service.yaml. So here I will try to add folder name, because folder name is missing. These files are part of K8's folder. So I'm going to update this real quick. This one step moves us from CI to real production. Now, if you look here above this particular lines, we are trying to load Docker image into the cluster. Our pipeline built a Docker image, but Kubernetes cannot see it automatically just because Docker has it. This is very, very important. Think of it like copying a file from laptop to a server. You might have a question, are we going to do the same in real production environments? We don't load images like this in real production environments. We use registries. We call it as container registries. For example, Docker Hub is, let's say, one of the registry, Artifactory, and we have some cloud registries as well according to individual cloud, Azure, AWS, GCP. But for this video, I would like to keep it very simple because everything cannot be explained in one single video. We'll make this production ready in the next episode, or maybe when I plan some other CI/CD series, advanced related. But for now, this is more than enough. Okay, we already talked about this deployment step, and then we are waiting for the deployment. All right, now let's jump to the real deployment.yaml file. What exactly do we have here and what we are doing? This particular line tells Kubernetes how to understand this file. Without this, it won't even run. You can try this. Followed by, we are using kind deployment. Here, run my application and keep it alive. That is what it means, kind deployment. Then we are giving the metadata. For example, name is production application, labels, application, production app. Then very important part, replicas. How many number of instances to run? You can add it as 1, 2, 10, 100, it depends. All right. In our case, we are keeping it very, very simple. One is more than enough. Followed by, if you scroll down here, we have the containers. Container name is production container. Image, if you see CI/CD prod, this is built by our pipeline. If you see Docker build -t CI/CD prod, I'm trying to hard code it. That's fine. This is just for clear understanding in real production environment. I know it doesn't work like that. We are trying to optimize it using variables and a lot of stuff. But my goal is to make sure you guys understand this very, very clearly. That's why we are trying to hard code it. We are going to improve it definitely. You guys can do that if you are interested. But yeah, I'm going to keep it very simple. Now, this is where CI/CD meets Kubernetes, where exactly the application runs inside, which is our container port 5000. If this is wrong, everything breaks. Now, this line, image pull policy, if not present, it tells Kubernetes if the image already exists, don't pull it again. In our case, we already loaded the image into the cluster using kind load. So Kubernetes just uses it directly. But in real production, this can cause issues. Definitely, I'm going to show that demo as well. Same image tag, new code, but Kubernetes might still run the old version. Small config change, very big impact. All right. Now let's jump back to our service.yaml file. So this is our service.yaml file. Deployment.yaml file runs your application. Service.yaml file makes it reachable. Very, very simple. Okay. Then we are trying to say specification type node port, means expose outside cluster. Followed by, we have a selector here. In here, production application, which connects to the deployment. So if you see production application, we have this selector here, which is matching with our service.yaml selector. All right. Then we have protocol port 80 followed by the target port. This must also match. So if you see, container port is 5000 and here the target port is 5000. Node port, this is what we use to access it. Without service, your application exists, but nobody can use it. I hope this is clear. Now let's try to add all these changes. Git commit -m episode 05k8's deployment. Let's push this. Let's jump back to the pipeline. And if you see, the pipeline is waiting for something. Looks like our runner is not available. Let's check that real quick. I'm going to go back here, click on runners, self-hosted runners, and I see the runner available. Looks like our runner is not online and not accepting any jobs. Let me look into that real quick. Yes, our runner is offline, connected to GitHub, listening for jobs. Hopefully it should work now. Let me refresh this. Let's go back to the pipeline. Yes, the pipeline is running now. The pipeline ran successfully, but it failed while loading the image to kind cluster. If you see, error no nodes found for cluster kind. Let me open the terminal and check kind get clusters. I can see the cluster, but we need to specifically define this name in this particular load image step. For example, -name followed by I'm going to paste this k8's deployment. Now let's real quick add these changes. Commit -m update cluster name. Also, if you remember in the whole series, we were trying to push changes to this particular folder and the pipeline was running automatically. There was no option to start manual trigger, which I am showing in this particular episode. Adding workflow dispatch, inputs, environment, description is select environment, required true. I'm going to add these changes so that we can easily trigger the pipeline manually. Now we have a run workflow step. I can select the branch here, main branch, select the environment, and then run workflow. The pipeline started once again. Now, if we look at the pipeline is green. And let's look at the steps. Load image into kind cluster, followed by deploy to Kubernetes and wait for deployment. Successfully rolled out. Now let's jump back to our virtual machine where we deployed our application and check if the pods are running. kubectl get pods. Yes, pod is running fine, and kubectl get svc. I can see Kubernetes cluster and prod service node pod as well. Pods are running, service is created. Now notice something very important here. Our pipeline built the image, it loaded it, deployed to Kubernetes, and waited for deployment. That's it. But it did not actually verify if the application actually works. And this is where most production issues begin. CI/CD pipelines don't guarantee working systems, they guarantee all these successful steps. If you are learning DevOps, Don't just learn tools, learn how systems fail. Subscribe because next we break this system on purpose and debug it like real engineers. Thank you for watching and see you in the next video. 90% of DevOps engineers stop at deployment successful, but they never check if the app is actually reachable. If you ever trusted a green pipeline without testing it, this episode is for you. Because today we are going to debug a real issue using AI. But before we start, subscribe if you want real DevOps debugging, not tutorials. And comment CI/CD. I want to see who is actually building pipelines. Now, in the last episode, we deployed the application, but we never tested it. Let me jump into the terminal and let's do the testing now. Curl space http colon slash slash localhost colon port 3007. See, this is the problem. Application is deployed, but the endpoint is refusing the connection. So the real question is not whether Kubernetes accepted the YAML, but whether users can actually reach the application. Let's test that. kubectl get pods. I see the pod is running. Now let's check the service real quick. And I see services, cluster IP and the node port. Pods are running, service exists, but that does not mean it's reachable. Let's quickly look at the pipeline now. So here we have AI debugging folder. In this folder, I have the same exact application which we were using in the previous episodes, and I created a new YAML file. If you see, here we have a new YAML file with 06 AI debugging path, and followed by, in this episode we are trying to create the cluster. Okay, in the previous episode we did not create any cluster. If you remember, I'll show that real quick. So we did not create any cluster. In this episode we are trying to create the cluster, and then one more important step here, verifying the endpoint. This was also missing in our previous episode. Without environment setup, nothing works. And without verification, you can deploy a broken system. Now let's try to describe the deployment. For that, I'm going to run kubectl describe deployment. If you look at the deployment, here it clearly shows one available, followed by, here we have the image name correct and port is 5000. This looks fine. Then let's look at the service. For service, I'm going to run kubectl describe service. Enter. If you look carefully, node port 3007 is exposed, and port 80 target port 5000 also looks correct. Finally, we are going to check the endpoints. For that, I'm going to run kubectl endpoints production service, and look here, port 5000 and the IP address endpoint. This looks fine. So let's recap it once again. Deployment is running, endpoints exist. Still we see port 3007 failed to connect. Now let's jump back to the application code. Kubernetes side debugging is over now. I'm going to jump back to the application code and look at the application code. This application listens on 5000, That means it is matching our deployment service is also matching. So the issue is not the application here. It's definitely somewhere else. This is where environment matters a lot. I'm using Kind, and Kind runs Kubernetes inside Docker containers. So node port is not automatically exposed to localhost, which means the application exists, but the host cannot reach it. The pod can be healthy, the service can exist, and the endpoint can still fail from the VM if the cluster is not exposing the port correctly. One thing was missing in the previous episode was actual cluster creation step. We were applying Kubernetes manifest, but we were not making the cluster setup part of the full pipeline story. That matters because if the cluster was created in the wrong way, the node port will not be reachable from the VM, even if the deployment itself succeeds. This is the point where I check if the cluster exists. For this video, I want to show that cluster creation is not something we should assume silently. It is part of the setup, just like the deployment and service. Let's check that. I can see this cluster is running right now. I am going to delete the cluster now. kubectl delete cluster hyphen name k8's deployment. Enter. I am deleting the cluster because if we recreate it, the networking is guaranteed to match what our configuration has. So now let's jump back to our application. Application is very simple. It listens on port 5000, which is correct for container. The deployment has port 5000 and and the service target port is 5000. So the application code is not the issue here. This is important because in debugging, we want to avoid guessing. We isolate layers one by one. Node port exposes port on each node in the cluster. In many setups, that means you can reach the application through the node IP and the node port. But this is where the environment matters. I am using Kind, and Kind runs Kubernetes nodes inside Docker containers. That means a node port is not always automatically reachable from localhost unless I explicitly map the port from the Kind container to the VM host. Now I'm going to ask AI for help, but I'm not going to ask any random question. I want to give it enough context so it can reason about the actual setup. So this would be my question. I deployed a Kubernetes app using Kind inside a VM. Here's my setup: deployment name, service type, service port, target port, node port, and then say the application listens on port 5000 inside the container. The pod is running and healthy. I am running the curl command from the same VM. When I run this, I get this error. What is the most likely cause and how do I fix it in Kind? Please answer in a short, practical way and tell me the exact Kubernetes or Kind configuration I should change. Press enter. So the key insight here, this issue is not with the Flask application, it's not with Kubernetes either. It's specific to Kind's networking model. Because Kind runs Kubernetes nodes inside Docker containers, the node port is actually exposed inside that container network, not directly on the local host. So even though I see port 3000 in the service, that port is not actually open on my VM, which means Kubernetes is working correctly, but my machine still cannot reach it. So the fix is not in the deployment or service, the fix is in how the kind cluster is created. I need to explicitly map that node port from the kind container to my VM using extra port mappings in this kind configuration. Now let's try to create kind config.yaml. Jump back to our Visual Studio Code, and I'm going to create that in this particular folder, kind config.yaml, and copy this kind cluster and paste it here. So we added the kind config.yaml, followed by we are going to jump back to our pipeline, and in the pipeline here we are using kind create cluster and the name of the cluster, followed by we are going to update this line with the config kind config.yaml so that it actually uses this configuration while the creation step. Save this file. I'm going to add all of these changes real quick. Git commit -m add AI debugging episode, git push. So the pipeline is running. Let me look at the pipeline, and the pipeline is failing. Kind create cluster config, yes. Fail to create cluster, error reading file, no such file or directory. Let me jump back. I know what exactly the problem is here. So the problem is k8 slash kind config.yaml. This is the problem. So if you see k8's deployment, k8's slash kind config.yaml. Let me push that real quick. Git add git commit -m update pipeline step. I need to save the file. Git add git commit and git push. Now let's jump back to the pipeline, and in the pipeline I'm going to refresh this real quick. This will not run because we did not change anything in the exact same folder, so I'm going to run this manually, and let's see the output now. So build a test deploy. It is trying to create the cluster now. Kind create cluster. This step is running fine. Once again, cluster got created, image got loaded successfully, then deployment is also success, but verification failed. But verification failed. Let's jump back to our virtual machine and try to run this command and see what exactly is happening. Application is running. That means it works. So there is some problem with the pipeline itself. Let me jump back to the pipeline. And if you remember, we are trying to verify the application endpoint, and there is no wait time at all. So we are going to fix that real quick, and I'm going to replace this particular step. Wait for application to reachable. We are using a simple for loop, and we are trying to wait and sleep as well here for 5 seconds so that application is reachable and the pipeline is not failing. I'm going to save this real quick and run this once again. Git commit -m update test step and git push. Now we have a green pipeline. Setup job, creating the kind cluster, building the Docker image, loading the image, deploying it to Kubernetes, waiting for deployment, and finally the application is running. The pipeline is green and we can trust this pipeline now because we have this curl test. Let's try it on the virtual machine itself once again. Application is working. Everything works. The same URL that failed before is reachable from the VM and also from the pipeline, which proves the problem was the port exposure and not the application. That is exactly the kind of issue AI helps with. It did not deploy the application for me, but it helped me focus on real root cause much faster. The very big lesson
Application is
here
running
is
now.
that deployment success does not always mean external access works. Kubernetes can be perfectly healthy and still not be reachable from your VM if the cluster networking is wrong. AI was useful here, but it helped us narrow the problem quickly. Instead of guessing, we checked service, pod, ports, and kind configuration. That is the value of AI in debugging. Not replacing understanding, but speeding up the path to the right explanation. And for production, I would not use kind the same way. Kind is great for local demos, but real production usually uses a managed cluster, a real node pool, and an ingress or load balancer instead of local host node port testing. That wraps up our CI/CD series. We started with a basic pipeline, built it step by step, deployed to Kubernetes, and then used AI to debug a real world networking issue. In the next series, we are going to switch gears and move into shell scripting, where we will build the automation skills that supports everything we have done here. Thank you for following along, and I'll see you in the next series.